Welcome to Home Education Matters, the weekly podcast supporting you on your home education journey. Hello and welcome to Home Education Matters, and today I am joined by Claire Johnson, and we are going to be talking about physics, and primarily we're going to be looking at physics at key stages 3 and 4, because obviously before that it tends to be just a more general science. So today we're going to be focusing primarily on the provision of physics when you home educate. So hello Claire, thank you very much for joining me today, and do tell us a little bit about yourself for our listeners.
Hi there. So I am a teacher. I'm a science teacher or by trade, but I left the classroom in 2021 now, and started my own tuition business last December. So I'm a home tutor. I tutor both EOTAS students during the day, and that's often face-to-face. And then I tutor online to home educated students as well, mostly for GCSE for maths and science. And I also have just started to branch out a little bit, taking on other tutors to do some of my evening provision. So I'm very much the home education tutor, but yeah, I had a lot of people asking for tuition outside of hours that I'm working and having a family, so they have to come first, obviously. My degree is actually in physics, so I'm a proper physicist. Did it while working, so I did my degree with Open University while working full-time as a HR manager, which is not like teaching at all. And then I went traveling around the world backpacking, and had my daughter, and I've gone into teaching because of the holidays really, and being able to spend more time with my daughter. So that's kind of where the career change came in.
What moved you from teaching into tuition then?
A lot of it was the workload. I'd also taught abroad, so we used to live in Spain, and I taught there in a British school overseas. So I think we had students from all over the world. We had a lot of Russian students, but all over Europe and Asia. So I was kind of with a lot of different cultures, and I had a lot of autonomy and kind of teach the way I really felt that students benefited from. And that was really, really, really nice. And then when we moved back to the UK, I kind of felt a bit disillusioned. Teaching had changed a lot. It was a very corporate feel, and I found that a little bit difficult to get back into, I think. And also there was the fallout from all the pandemic. There was a lot of students who had real health problems that hadn't been dealt with well enough, because there just wasn't the pre-planning. You can't plan for a pandemic, can you? So that was another thing that I kind of felt like I could help more by working on a more one-to-one level with students rather than in a mainstream environment, really.
So you found that when you were teaching in the school setting, it was very different, I'm guessing, in the Spanish environment, was it, to the UK, and that when you came back to the UK, it felt somehow more constricted. Is that what you're saying?
Yeah, for me it did. I think in the Spanish school, I think I felt trusted as a professional more than in the UK, and also a lot more respected by the students and the teachers. The parents. I feel like in a lot of cultures, education is treated differently to how it is in the UK. Yeah, I don't want to get too political really, but I do feel that it's I think education is really celebrated in a lot of cultures, whereas in the UK at the moment, it isn't so much.
So you must find that when you're doing one-to-one tutoring, it's a different kind of culture, because the parent and the child have both actively sought out tutoring. So they've sort of bought into it more than perhaps they would if they're just in the school system.
Definitely. A lot of the time, though, the students that I'm tutoring have come to a crisis point. there's different kinds of student that I'm kind of tutoring at the moment. So those really are probably the EOTAS ones, the ones that really feel like they've been failed by the system, and they're desperate for help, and they're probably looking more at the maths rather than the science. They just want to get the maths and English done and be able to move forward and move on after some quite traumatic experiences within the education system, and also trying to fight to get the help that they need and they feel that they deserve. A lot of parents and students have been through years of fighting at that point. So once they've got EOTAS budgets and they can then access the education, a lot of it is kind of moving through that trauma. So it's not just here's the content, let's go through the content. A lot of it is helping break down that trauma of education and trauma of the system, and trying to rebuild that trust again. And then of course the content comes afterwards, but we have to really treat the person as an absolute individual at that point, and really focus on their needs. But then we have the elective home educated students who have taken me on board for a completely different reason, and so I have to treat those completely differently to how I would with the EOTAS students. And then the students who are mainstream as well. So if I'm tutoring revision as a booster class before the exams, that's another completely different thing. But you're right, they've already bought into the idea of tuition, and it's really rewarding actually, because I can focus on that child completely and what their needs are, and I can assess using my teaching skills kind of what they need at that point, and then really progress them. And even within the small groups, they tend to progress very quickly.
How important is it that there's a practical element that runs alongside the theory, and how do you work with that when you're tutoring home educated children?
It can be difficult. I think some students really don't want any practical. They just want to know the information, want to know what they've got to learn to put into an exam, and that's the end of it. But actually most of the students that I've got really do enjoy the practical, and they tend to like quietly chuckle to themselves if I say that, oh, we're going to do a practical today. You can just see their eyes light up, and that kind of silent chuckling, like, yes, what are we going to get today? It just takes a little bit more organization in that you need to be able to prepare the parents first of all, because and especially with online, is that you need to have the equipment there ready. So I still think it's really important, because we assimilate knowledge in different ways, don't we? And to do something that's a bit more kinesthetic, and where you're touching things and feeling things and seeing things, you tend to remember those experiences more than just a repetitive routine kind of lesson. As I say, if you're a little bit creative and get online and have a look at other people's ideas and steal ideas as much as you can when it comes to practicals, there's some brilliant things on Pinterest and YouTube, and the home ed community is amazing for their collaboration with each other, and the ideas that they share with each other. So there's so much you can do for science at home, that with a little bit of forward planning, you can send an equipment list. I always feel that I need to kind of go a little bit overboard with the safety, so I will kind of say, he'll be using a kettle, so please make sure that it's a safe environment and that you're around in case there's any issues, and that he knows what to do if he burns himself or anything like that. But then also I do say he won't be doing anything more difficult than making a cup of tea, though. So just to put things into perspective, and a lot of the practicals are fun. Like we can do chromatography practicals at home, and convection currents. I mean, we won't be using potassium permanganate, but you can get those dental disclosure tablets, which work just as well. So there's lots of different things you can do, and still kind of have fun and have that practical experience. And then especially for GCSE with the set practicals, I would say, well, I know we've done it this way so that you can see the effect, but in the exam, this is the equipment that you would use. This is what the diagram looks like. And we just talk it through. The other thing as well is setting things for homework. So, I mean, I have done practicals with water around a laptop before, but if it's something that's going to be dangerous or could cause something to be damaged, just me talking through it or showing a video or me modelling it and then setting that for homework with an instruction sheet, it can be done. You just have to try and find a way to make these things work.
Yeah, and I did a very interesting podcast about the Charlotte Mason approach, and it was actually, I think it was called something like the Charlotte Mason approach through exams or through the exam period, because I know that the expert that I talked to there, the Charlotte Mason expert, said that she taught her children their GCSE sciences almost solely through practicals. So they would do these practicals, then they would talk all about the sort of theory behind the practicals. And there's no doubt that it is a really nice routine. You know, you mentioned about how the child responds when they know that it's going to be like a practical, that lesson. And it reminded me of when I was at school and they would wheel in the TV. That's how old I am. They would wheel it in on a trolley, and you could sense that kind of palpable excitement that, oh yeah, it's a TV lesson. And it's very much like that with practicals, isn't it?
Yeah, and it was even more special when the teacher before had forgotten to rewind the video and you knew you had about 3 minutes of chatting to your best mate about what we were going to do after school.
That is so true. I remember that too. So talking about practicals, I'm guessing that, just for our listeners, that's why we as home educators do the international GCSE or the IGCSE as opposed to the GCSE. So just tell us a little bit about the differences between the GCSE and the IGCSE when it comes to physics.
There's not much difference when it comes to the content. I will say I'm only familiar with the Edexcel, the Pearson IGCSE. I've tutored Cambridge once, but not for physics. That was just as combined science. So for physics itself, probably just talking about the Pearson Edexcel IGCSE. So yeah, content-wise, there isn't much difference. There's a few topics that are on the GCSE that aren't on the IGCSE, or subtopics really. So things like lenses are on the GCSE but not on the IGCSE. Upthrust comes up in the GCSE rather than the IGCSE, but each GCSE is slightly different. So OCR, AQA, and Edexcel, they all have slight differences in their content. So as a science teacher or a specific, if you have a specific science that you teach, you are quite used to, when you move schools, adapting to the content that you teach anyway. So I think it's really important that for somebody that's home educated, if they're looking at doing a GCSE, that even then the resources that you're using, make sure that they are compatible with the board that you're using, because of these slight differences in content. But the general content will be almost the same for all of them. It is just these kind of sub parts of the specifications that are different. It's more about the way that it's examined that's different. So for the IGCSE, there's 2 exam papers, like most of them do have 2 exam papers, but the practical element is examined through the papers rather than an exam centre signing off to say that you have completed the practical side of things. So you need to be really good at describing methods, analysing results, being able to do a mean from a table, from data, drawing a graph, and all of these things that are assessed. And a lot of those skills are also still assessed in the GCSE as well. But because the set practicals are not assessed by the exam centre or signed off by the exam centre, then they are kind of assessed in detail with the IGCSE. So you need to know those assessed practicals or required practicals really well. So I would definitely spend time on those. The other thing is with the GCSE, they tend to do half of the content assessed in paper 1 and then a second half of the content assessed in paper 2. So you revise half of the amount of stuff, dump it all on the paper for paper 1, and then do the second half of your specification and learn that for paper 2. And with the IGCSE, it's not that simple. You need to know all of your content for paper 1 almost, and then all of your content for paper 2 as well. So,
sorry, what's the differentiation then between the two papers?
So paper 1 is used for both the combined science, which is called double science for Edexcel, and the physics students. And then this paper 2 is only done by the ones that are doing IGCSE in physics, not the ones that are doing combined science.
So it's harder physics.
It's not necessarily harder. It's not meant to be harder. It's just different content. So what would happen is you're not allowed to do the combined science route and the physics route. They're combinations that aren't allowed to go together. So you need to make a decision. Are you going to go and do combined science, or are you going to do the sciences separately? And if you do separate sciences, you can choose to do all 3, biology, chemistry and physics, or you could just choose one, or you could choose your 2 favourite. And a lot of home educated students that I've got, a lot of them do just pick 2 that they like, or pick the one that they like. So that's quite nice. It gives you that choice. With the combined science, you've got 2 routes as well. You can either do just a single award science, or you can do a double award science. So they're all assessed to the same level. So they're all grades 1 to 9, achievable in all of them, all of the papers. But it's different content. So a single science will have less content than the double science, and then the double science has less content than the separate sciences.
Okay. And when it comes to the 2 papers for physics, the Edexcel, which to be fair, most home educators do, is the Edexcel IGCSE, the discrete sciences, like the individual sciences. I don't know much about the Cambridge specification. Is there a big difference, do you know?
I've only taught the Cambridge combined science, and there wasn't much of a difference. I did find that the questions, the level of English within the questions, I found a little bit more difficult. So I felt, I was with my international school at the time, I felt that it was a little bit harder to access the paper and harder for the science to be assessed, because a lot of the students would trip over the language in the question.
I've heard that with Cambridge, actually. I've heard that, and I've experienced that with Cambridge IGCSE papers, is that the actual wording of the questions is not always, it's a bit more opaque sometimes. When it comes to the 2 different papers, you have paper 1, which is 2 hours, is it?
Yeah, 2 hours and 110 marks. So normally say about 1 mark per minute. So it doesn't give you that much time to check your answers and things like that. It's quite a fast-paced paper. There's a lot in there.
And what about paper 2?
Paper 2 is 1 hour and 15 minutes, and that's 70 marks.
Yeah. And so that sounds like it's short, intense, sort of like...
Yes.
Yeah.
It is. A lot of students like the paper 1, and they kind of feel comfortable with the content. They feel... although it's longer, it's quite doable. And then they get to paper 2 and they do find paper 2 harder. I do think some of it is the content. As I said, it's not meant to be harder content, but students do tend to find the topics that are on paper 2 only a little bit harder. You've got things like static electricity, which students can struggle with the explanation part of that. Then you've got things like momentum and moments, and they can be tricky. If you make a mistake in a moments question and it's a difficult one near the end of the paper, then it can throw someone. So it is demanding. But physics itself, I think it is a demanding course, but it's it's a very rewarding course as well.
That actually, I was going to ask you that, but before I do you think that paper one and paper two assess different skills? Because I know, for example, in something like history, which obviously is very different, you have paper one, which is more like analysis, then you have paper two, which is source work. And with languages, you have reading papers and listening papers. Is it different skills that are assessed in the two different papers? Or because it doesn't sound like the content is hugely different.
No, it's not. I think it is pretty much the same skills in both papers. So you'll have different types of questions, so multiple choice, explanation, data, but the actual skills assessment kind of throughout both papers is pretty much the same. It is just that you've got that content that's just for the separate science physics that's assessed in paper two, but they still do the different skills throughout that. So you'll have some data analysis, you might have a graph, there's some application of the science knowledge. So yeah, I would say that both papers, skills wise, are pretty much the same.
Okay, and so that leads me on to the question that I was going to ask you about where physics fits in with the other sciences, because obviously there's 4 sciences that home educators can sit. And I normally put biology down as maybe the one that has the most memorizing, but not, and the least maths. I tend to put chemistry down as quite high maths, but not hugely difficult. I have physics, I'm trying to do these in order. I have physics then as difficult and maybe one you would want to do later. And then I have astronomy, which has, from what I can gather, the hardest maths, but the funnest content. Okay, so this is a complete layperson's approach to science. Is based on my son did all 4, so I'm trying to think of how they panned out. So would you say that physics fits in towards the harder end of sciences?
This is a difficult question for me to answer because I am a really strong advocate for physics not being hard. I think the course is demanding, but I think we need as a society to try and break down this whole barrier of physics being hard or physics only being for intelligent people or for clever people, because actually physics is used by people, by adults all the time, and they don't find it hard in their real life. I think I really am an advocate of physics is for everybody. So trying to answer the question without kind of backtracking on my own kind of ideology there is going to be difficult. But I think, yeah, a lot of students probably do find that there is a lot more maths in the physics. But if you can rearrange an equation or a formula in maths, which isn't the highest demand if you think of how many variables you'd have, most equations in physics have 3 variables. So most people, even that are doing a foundation paper, can rearrange an equation or a formula with just 3 variables. So that means that that's actually most of the maths there is done. If you can substitute into an equation, then again, most of the maths is done. So, a little bit on significant figures and rounding throw in there. So a lot of the maths isn't that difficult.
What about the concepts, though? Because physics has quite big concepts, doesn't it?
It does, and I think I think we need to tackle how we kind of look at these concepts from earlier on in our education, because I find that I often have to fix a lot of misconceptions as a GCSE tutor, and that's a lot harder sometimes than if we kind of catch students at the right ages. As a home educator, I would really look at a lot of the kind of work that's been done that's research based. So things like stem.org, they've got their best evidence science teaching, and that shows how children conceptually build their understanding of the world around them. And it's fantastic at kind of picking up these misconceptions that students have, and that really does help break down a lot of the conceptually difficult things, because you can really work and understand them in a different way. And that's really some really good research that's been done there. The Institute of Physics has often kind of, if you follow them on Twitter or their Facebook pages and things, they often bring out things as well that are quite helpful, that are more physics based. And I know they're also very much at the moment a physics for all. So there's a lot of, if you're interested in that, there's a lot of work being done by them, especially this year. But yeah, I would actually say that's where I'd put most of my work if I was starting my physics journey, in kind of with the idea of having a GCSE in physics. I would spend more of my time worrying about how do I understand the concepts within physics and how do I explain those to another person who might not understand those concepts in physics. If you can do that, that would be a lot more beneficial than spending hours worrying about equations, because although equations is a big part of the marks, I suppose, it is one kind of skill or a couple of skills that we're just repeating. So as long as you've got the maths behind you, that bit's not too difficult, but you've got to be able to understand the physics to enjoy the content, really. And if you enjoy the content, then you can pass your GCSE.
And what about A level? What are the options for people that want to go on and do A level physics from home?
So you can do the international A level. So you could do that as the AS or the A level, which the Edexcel IGCSE, that leads on to the A level, the international A level, and it's a good preparation for that. So I mean that was definitely more my mum's actual territory in my old school. We're both physics teachers. So yeah, she's definitely the one to speak about that. Sorry, I've been interrupted. I've got my 4-year-old here. Sorry about that.
No worries. So I have one last question that I wanted to ask you, and that was about the move from GCSE to IGCSE, because you mentioned that with all the specifications and then with GCSE versus IGCSE, that there was a slight difference in content, but you implied that there wasn't a drastic difference. So for a lot of home educators, there's a number of resources online for GCSE sciences that maybe aren't available for IGCSE sciences. And a lot of people, they know that they want to prepare for the IGCSE, but the cheap and the easy resources are there for GCSE. So at what point would you recommend that they make a jump from GCSE to IGCSE before the exam? Like how much time would they need to cover that little bit of additional content that isn't covered with the GCSE resources, for example?
I don't think it would take that much, but really I would probably start, if I knew that I was going to take the IGCSE, I would plan my curriculum based on the IGCSE from the start, because I think the way the specification is written, it helps you to see whether the links are going to be made between one part of the specification and another part of the specification. So I would definitely kind of say, if you were going to do topic 1 on forces and motion, I would find out what's on the specification for the IGCSE, and then for each specification point, then go and borrow that information from the GCSE stuff that's available, definitely, because a lot of it, the physics isn't different. But just being able to organise it in your mind and in your brain, in the way that the IGCSE is organised, would be much more helpful, because even though the content's very similar, as I said, there are these sub points of the specifications that are different. So they are just slight differences. The way that they're organised and ordered is very different. So OCRs kind of starts with the model of an atom, whereas, that's not even in the IGCSE. So I wouldn't even kind of waste time learning content that isn't on the specification. I would just focus on what the IGCSE has.
Yeah, that's good advice. So you would recommend printing off the specification for the IGCSE and then saying, okay, topic 1 is forces and motion. I can then find a GCSE resource that deals with forces and motion, and then you'd go on to the next thing on the IGCSE specification and then look for a resource based on that, right?
Yeah, definitely. I wouldn't necessarily teach the IGCSE in order. I would do it by topic if possible, but for instance, in my groups, I do tend to move around a little bit differently, because I personally feel that say momentum and moments are put next to each other on the IGCSE specification, and I find that students then muddle them up because they sound similar, but they're
They do.
completely different things. So I tend to do momentum, and then I'll leave moments, and then I'll do moments kind of in a few months' time, which also gives me a chance to revise some of the forces things. I also find that energy, it's topic 4 in the IGCSE. I tend to bring that forward and do that before I do waves, which is topic 3. Just because I find that sometimes within waves, we're talking about energy. If we're talking about, say, the energy of an electromagnetic wave, the students don't really know what I mean by energy. So, and energy can relate to forces when we're talking about, work done and things like that. So sometimes students get a bit confused, is this force or is it energy? So by teaching them together, I can really distinguish, this is the force kind of topics, this is what we're talking about with force, and then this is energy, and this is how they can cross over, and this is okay. But there's very specific language that we need to use with energy, so it helps kind of develop the forces a little bit more in depth. So I like to do energy after forces. And then the later topics, kind of topic 5, some of that you could do very early on. The model of the atom, for instance, it crosses over really nicely with chemistry. So you could do that then, or you could leave it in topic 5 and it's like a revision of chemistry. So I do kind of leave it in topic 5 normally myself.
If you're doing physics, is there another science that lends itself nicely to running alongside it? Would you say that it's chemistry?
Yeah, I think so, chemistry. There is this with the states of matter kind of part, there is quite a bit of crossover in that sense. And with chemistry, you're talking about the energy of a reaction and things like that. So that's bond making and bond breaking. There's a bit of crossover there with the physics, and then changing states and things like that. So I think physics would kind of do it a little bit differently to the chemistry, but a lot of my students I'll have for chemistry and physics, so I can link the two and kind of say, well, for your chemistry exam, make sure you include these points. For your physics exam, you've got to see it from this perspective and include these points. But it's nice to be able to revise the other one at the same time, which is good.
Yeah, that's really helpful. And it's really helpful to get a sense of that you don't necessarily have to do the units in a very linear way. You can mix them around and do them sort of in an order that feels more logical to you. So do you have any other sort of big tips that you would give to people that are helping their home educated child do physics at home?
I would definitely keep topics 6, 7, and 8 till the end, because they really are. You can't really do topic 6 without having done topic 2. So that's topic 6 is magnetism. You need to understand electricity really and have done a little bit on waves maybe before you can do the magnetism side of things. Then topic 7 is all your nuclear physics. So so that can kind of be done a little bit later. And then the astrophysics in unit 8, that's a lot of that is kind of application of your waves from unit 3. So it's difficult to do that without having done unit 3 first. So I would leave the last 3 till later. As for kind of exam kind of technique type things, I would really focus on with the equations, as I said, don't focus too much on learning equations all the time, because that bit's not actually as difficult as people make out. I think the specification has a list of equations that it doesn't give you. So they're the ones you need to learn. So put them on cards, learn them at breakfast. That bit can be done over, the period of time that you've chosen to study before you take the exam. You can fit those in and learn those. And if you're practicing using an equation, which you'll need to do, then if you're writing out the equation at each point you're practicing, then you will learn the equations off by heart anyway, because you're overusing them, which is good. But I think understanding where the equation comes from is the key, because, for instance, if you look at speed equals distance over time and you look at a distance time graph, then you can see that the equation's coming from the graph and the gradient is the velocity. And you can then use the equation to help you work out the units. You can use the equation to help you form an explanation. You can use the equation in a method. So you could, if you've been given a method and you need to work out the speed of something, you can say, right, what's my equation? Okay, speed equals distance over time. Right, so I'm going to measure the distance. What would I measure the distance with? With a ruler. And then what else have I got in my equation? Oh, time. I am going to measure the time using a stopwatch. So it's being able to use the equation as basically that is your kind of what do they call it? Your cheat sheet, really. Is if you know all the equations, they give you so much more than, oh no, it's just an equation I've got to learn. It's actually a tool that you can use in a lot of the questions. If you're doing an explanation, write the equation in there and use it and say, well, if this goes up, then this must go down. And, you can use it in so many different ways. So don't be afraid to use the equations to your advantage, I would say. Using the command words is so important. And this is across the board, not just physics, not just science, but every exam is, what is the question asking me to do? If it's saying to explain something, then you've got to say why that's happening. Don't just tell me what's happening. Tell me why it's happening. What is it that's making that happen? Comparing things as well. I think students are not so good at comparing and, being able to say, well, this happens, whereas, in this one, this doesn't happen. So, for instance, a renewable and a non-renewable energy resource. It's having that confidence to really analyze and evaluate the situation. And these are your kind of application skills, because 40% of your GCSE for physics is going to be about recalling different facts for physics and knowing what an equation for acceleration is, knowing the units for momentum, these kind of quick recall things. But then another 40% is how you can apply that and knowing, how you can analyze the situation. So, and I think it's that 40% that students miss out on. So if I was to give you a clue of what to do, is really work on that 40% that a lot of students just don't have enough experience of.
So taking the existing knowledge, the formulae, that kind of thing, and then applying it to alternative situations and applying it to different questions.
Definitely. So, and they do this a lot for, say, electromagnetism, static electricity. They'll give you ideas of what they want you to be able to explain. So how does a smoke alarm work? But then they'll give you a different situation in the exam, and they want you to almost say exactly the same thing as it would be for a smoke alarm, but for a different situation. They want you to be able to recognize that and be able to use the knowledge that you have and make sensible suggestions of how something completely new would work based on the physics that you know.
I think that's so useful, because I think there's so much of the exam paper contains information that is helpful for other questions. And I see that in so many subjects. And it's interesting you say about command words, because I quite often refer to exams as like a hoop jumping exercise. Well, I see command words as like the instruction manual for how to jump through the hoops. It's so vital that you understand what each command words means. And of course, they mean different things sometimes in different exam papers. So just so you know, if you know what describe or explain means in a physics question, it may mean something completely different in a history exam, for example. So command words can mean different things with different specifications and with different subjects as well, right?
Yeah, definitely they can. And I don't know if a lot of parents know, but the specification for Edexcel, they literally have a list of command words, and it's really, this is why I like this as a specification, because it really is so clear how you can help yourself in that perspective. I think the hard thing is probably finding the content, but lots of past paper questions as preparation for the exam would give you enough of a broad range of questions to show how they might ask you to apply your knowledge to something else. So that's where I would try and I'd use those as resources to gain the experience in that, because you do need to learn the content first and practice your equations and practice things, but that application really does come later with the practicing of the exam questions.
And are there any other resources or YouTube channels or online things that you would recommend that our listeners could use, free resources that they could use to supplement their learning at home?
So I mentioned before the best evidence science teaching. They do have a lot of free resources, and they help you choose an order. So if I was to go from the start, I would use that to kind of give me like ideas of the order of teaching, and then the specification as well, and use that and kind of think, well, okay, I'll do forces first, and then I'm going to do energy, and then I'll do waves, and then I'll do all that sort of thing. And it does pick up on those misconceptions. However, that alone would be quite dry and a bit boring and a bit repetitive. BBC Bite Size is actually really good for science. For physics as well, you might not get it all from, say, Edexcel. And think there's some topics, for instance, like the critical angle, which is better going into their A-level physics for some of that, and the WJEC board. And sometimes the Scottish boards are a little bit better with their content for certain things on the IGCSE. So don't feel that you have to be restricted to the Edexcel GCSE. There's science videos, is it Cognito that come up? They're pretty good. I've used those for some chemistry and physics. But and Oak Academy used to have some pretty good practice for certain for certain formulas. So you could pick up, say, the speed formula, and then they'd give you a few questions, and they extend it so you could see how something might be asked a little bit harder. But I have heard that some of those science resources have gone. I haven't checked them for a while, so I'm not sure. You might need to check those. I don't think the physics resources out there are brilliant. There's not a great deal of of a go-to place where there's lots of things in one area that's all free. I think it's something that does need to get a little bit better.
I know that we used a YouTube channel called Physics with Keith that was quite popular with us, and also Science with Hazel. I think they were both quite helpful YouTube channels. But for those, I know that science tutors are massively in demand and oversubscribed, but for those of our listeners who might want to get in contact with you, Claire, and might want to sort of follow up on having tuition with you, could you let us know your social media links, your website link, that kind of thing, so any of our listeners could get in touch if they wanted to?
Yeah, my Facebook is probably the easiest one, which is Miss Johnson Tutor. And then I've got the link tree on there that kind of shows you to everything else, and you can get in touch there. Yeah, so that's probably the easiest one. I am on Instagram as well, but nobody seems to go on Instagram for that. I don't know if it's going to be emerging at some point, but no, it tends to be the Facebook groups and things. I think I do tend to kind of be there on the home ed, offering advice on science quite a lot. So I think a lot of people probably see me as Miss Johnson tutor.
Yeah, and Claire will be on our Facebook group that is linked to this podcast, where we'll put any links up that we mentioned and also links to Claire's tutoring. So Claire, thank you so much for coming on today and guiding us through the world of physics. I know that, yeah, I know that I'm not great with science, but my son loves science, so he's forced me out of my comfort zone when it comes to sciences. But you've given us some really good practical information about the exams, but also some really good advice about how to tackle the actual papers and the sort of things that they're looking for and how to revise and how to study for it. So thank you so much, Claire. It's been great having you on the podcast today.
No problem. Thank you ever so much for having me.
Thank you so much for joining us for today's Home Education Matters podcast. See you at the next one. Have a lovely day.